Hi, my name is Joe Exel. I work for the Northwestern Indiana Regional Plan Commission as a water resource planner. Sorry we couldn't be together in person today for the Science Symposium, so we're going to go ahead and try this virtually. What we're going to be doing today is we're going to be heading down to one of my local streams by my house. I just finished loading up my Jeep with some sampling equipment, and we're going to talk a little bit about how do we monitor a stream's health. So this morning we're going to head over to Lake County Park site, Deep River Park, not the water park site. This is the location where the old mill is at. It's a beautiful wooded property that goes along the river. But what's really kind of interesting about this location is it has some of the highest quality habitats and water quality within the Deep River watershed. Now, a watershed is simply just the area of land that drains to a particular point on a water body. Watersheds come in all different shapes and sizes. We all live in a watershed. And why understanding what a watershed is and why it is important as far as stream health is because whenever it rains or it snows and that snow melts and runs off across the landscape, it's got the potential of picking up harmful pollutants and delivering them to our receiving water bodies such as Deep River. Not all of Deep River is in kind of a natural conditions. As I mentioned, the park that we're going to is largely wooded. There are large portions of the Deep River watershed that have been developed for us, where our houses are, where we go shopping, to even some of the farm fields. So all these potential areas may or might not affect water quality. It just depends on what we're doing on the landscape and trying to protect streams and rivers. There are three different ways that we can monitor how healthy or unhealthy a stream is. The first way in the topical area most people are probably most familiar with would be water chemistry. Now, water chemistry can evaluate a number of environmental factors that are important for protecting aquatic life and even recreational use of our water bodies, such as a stream. Some of those factors include the amount of oxygen that is available in the water. We call that dissolved oxygen. Dissolved oxygen is really important for supporting diverse and healthy fish communities and other forms of aquatic life. Then there are other factors such as the amount of nutrients that might be available or being carried within the water. The most important nutrients that we typically would be looking at would include things like nitrogen and phosphorus, both of which are naturally occurring in the environment. But whenever you get human land uses involved within a watershed, you have a potential of having too much nutrients delivered to a water body. In a worst case scenario, and something maybe you've all seen before, especially like during a hot summer day, is let's say you're driving down the road and you see a lake or a pond that is just pea green in color. That's because there's too much nutrients in the water. That is algae. It's an algae bloom. Responding to most likely excess phosphorus in the water, in some cases nitrogen as well. A little bit of nutrients is okay. Having too much is bad for the environment and can be very bad for public health too. Another factor we can look at as far as water chemistry is looking at the amount of sediment that is being carried within the water column. Just kind of like with looking at nutrients where excess, you can kind of get that pea green color. With sediment, what you wind up seeing is a river that looks muddy. So those are three of the major water chemistry factors that we can evaluate, whether it is a professional scientist, say somebody from the Department of Natural Resources or Department of Environmental Management out assessing streams. Or, I mean, even volunteers that might be participating in a program like Hoosier River Watch, which is a statewide volunteer stream monitoring network. The other way that we can evaluate how healthy or unhealthy a stream is to look at the habitat that is available within the stream and the habitats existing next to the stream. It's a factor that is often overlooked in regards to stream health. Just because you have good water quality, like say you have really good dissolved oxygen levels and nutrients aren't too high, that doesn't mean that there might not be a problem with habitat quality. For instance, a natural stream channel within our landscape here in northwest Indiana is typically going to meander as it flows across the land. And a meander just means that there are bends that occur in the river. That would be what we would normally see in natural conditions in a landscape like ours, as opposed to like a ditch, something that was just excavated for the sole purpose of moving water off the landscape as quickly as possible and efficiently as possible. So with like a ditch, that is meant to kind of drain the landscape. It doesn't matter if it was for agricultural fields or even for drainage for housing development. Most aquatic life is not going to like to live in stream conditions like that. There's very little habitat variability in a channelized or a ditch compared to natural stream conditions. So we typically expect to see very tolerant organisms growing in there. Things like carp might be an example that most people would be familiar with. Things that have evolved over time to handle really kind of rough conditions, as opposed to like a meandering stream that is nice and shaded, where we might expect to see, like for instance here along the southern tip of Lake Michigan, trout and salmon. So habitat is very, very important. Habitat quality, I should say, is very important to help assess how healthy or unhealthy a stream is. The final way we can assess the health of a stream, and one of my favorites, is actually look at the aquatic life itself. While water chemistry provides us kind of a snapshot, just a moment of time, how healthy the stream might be when we grab that water quality sample, when we go out and we monitor aquatic life, what that is providing us is more kind of a long-term impacts that have happened to that river. It provides a larger window on what those organisms might have been exposed to, whether it's water chemistry changes or even changes to habitat. So today, what I'm going to go ahead and show you all how to do is how we can use aquatic macroinvertebrates to assess stream health. Now, aquatic macroinvertebrates, if we just break that down, aquatic meaning they live in water, benthic meaning they live on the bottom, macro meaning we can see them with the naked eye, and vertebrate meaning they don't have a backbone. So these are going to include things like snails, insects, clams, mussels, things like that. All those things are potential indicators of water quality and habitat. Next, I'm going to show you the equipment that anybody can use to go ahead and assess stream health. Collecting macroinvertebrates is relatively simple from a river. You don't really need heavily specialized equipment to do so. So for instance here, I've got a very simple sweep net. You can use something like a butterfly net, or if you've gone through the Hoosier River Watch program and had the training, you can check out some of their monitoring equipment, which includes a net just like this. I also have a little wash tub, preferably something with a kind of like a white bottom or walls would be would be great to have. It makes seeing the macroinvertebrates a lot more easy. Also, I had access to some spoons at home and some plastic cups. So that's actually what you need there for the collection. I also happen to have a pair of waders. The water is still a little bit cool, and since I do some stream fishing, I've got my own pair of waders, so you can see the boots and the waders themselves, then a notebook. It's one of the beauties of monitoring for macroinvertebrates equipment-wise is there's really no special need, and you don't need permits to go ahead and collect and monitor like if you were to do a fishery survey. So relatively simple setup here. Here's a section of river that we're going to be monitoring on Deep River. Go ahead and looking downstream right now, you can see this little sandbar in the middle of the stream channel on the opposite bank. You can see a little bit of rocks along the toe of the slope, and you can see some tree roots that are currently above the water. Water is moving a little bit more quickly on that outside bend, which one would expect, and a little bit slower on the inside of the bend here. And moving downstream, you can see this is a nice wooded corridor, and you can start to see kind of the little glimmering and ripples on the water. That's what's known as riffle habitat. This is one of the few locations here in northwest Indiana where you have conditions that are favorable to providing this type of habitat for aquatic life, that being the riffle habitat. And the inside of this point, you can see this big old pile of sand. Deep River is very dynamic in this stretch. All the sand was not here last year, so that means that this all accumulated over the winter and this early part of the spring after flood flows carried sediment down, sand in this case, from upstream sources. So this is the area that we're going to go ahead and be sampling in.